Good morning, class. And this is chapter 2, limits, section 2.2, limits of functions at infinity. So we covered limits of sequences, limits of functions at infinity is today, and coming up, limits of functions at finite numbers, algebraic method. So here's the synopsis of what we have covered. A sequence is an ordered list of numbers or function f whose domain is the set of natural numbers 1, 2, 3 to infinity. Limit refers to the long-term behavior of a sequence, i.e. what happens to a sub n of a sequence in the long run. Limit of a sub n as n approaches infinity equals L. We say that a sub n converges to L. Limit of a sub n as n approaches infinity is infinity. Negative infinity or DNE does not exist. We say the sequence diverges. To find limits, simply plug in and observe. And here's one of the theorems. The limit of r to the power of n as n approaches infinity depends on the value of the base r. If it's between -1 and 1 is 0. If it's 1 is 1 and it's larger than 1 is infinity. The limit of 1 over n to the power of p as n approaches infinity is 0 as long as p is positive, because if you have a negative exponent, it comes up and it becomes positive. So p has to be positive. And here's the geometric sequence. Add them up becomes geometric series. The summation of a r to the power of n minus 1 is a times 1 minus r to the power of n over 1 minus r. If r is between -1 and 1, this goes to 0 according to this part and becomes a over 1 minus r. And in a case of a geometric sequence, b sub n plus 1 is r b sub n, or b sub n equals b sub 0 r to the power of n, b sub 0 or a. That's a basic geometric sequence. For medication, we add a constant, and it gives us the formula b sub n equals b sub 0 r to the power of n plus c times 1 minus r to the power of n over 1 minus c. And dealing with the patients, almost always b sub 0 or a is 0. B sub 0 or a is always 0. And now, 2.2 limits of functions at infinity. Here's the summary definition. Horizontal asymptote short HA of the curve y equals f of x is y equals L if the limit of f of x as x approaches minus infinity is L, or limit of f of x as x approaches infinity is L. So that's the definition of a horizontal asymptote. For example, the limit of 1 over x as x approaches infinity is 0. The limit of 1 over x to the power of p as x approaches infinity is 0 for p larger than 0. And in both cases, therefore, y equals 0, which is the x-axis, is the horizontal asymptote. Some of the functions we are familiar with. This is an exponential function. It's an exponential growth because b is larger than 0. So y equals b to the power of x. That's also an exponential function, but b is between 0 and 1. It makes it an exponential decay. Therefore, as you can see, the limit of e to the power of x as x approaches minus infinity is 0. The limit of f of x as x approaches infinity is infinity refers to the first quadrant. In this case, the limit of f of x as x approaches negative infinity is infinity refers to the second quadrant. However, the limit of e to the power minus x as x approaches infinity is 0 as an example, and which makes y equal 0 is their horizontal asymptote. A function everybody is familiar with, y equals x cubed. The concept of finding the limit as x approaches negative or positive infinity, okay, is known as the end behavior. The limit of f of x as x approaches negative infinity is negative infinity. That means the third quadrant. The limit of f of x as x approaches infinity is infinity. That means the first quadrant. And this concept is known as the end behavior, everybody. So the end behavior. All right. We want to take the limit of this rational expression, the limit of 3x squared minus x minus 2 over 5x squared plus 4x plus 1 as x approaches infinity. I've discussed the technique and we will go that route ultimately, but just to get us warmed up, we are going to follow limit laws by taking the limit of the top over the limit of the bottom. So the limit of 3x squared minus x minus 2 over x squared, 5x squared plus 4x plus 1 divided by x squared, because this is approaching infinity, we are dividing by the highest degree term in the denominator x squared. We get to the following. So right here, I would go to the final answer, but just to follow the limit laws, as I mentioned, I meant for the limit laws right here, we go with the limit of the numerator as well as the limit of the denominator. In other words, cut it into two limits first, limit of the top, limit of the bottom. And now each one we cut it into three pieces. This is just for practicing limit laws. As far as I'm concerned, right here, we can go to the final answer. I'll show you in a moment. But when we separate them, this becomes 3. This becomes 0. This becomes minus 2 times 0, 0. This becomes 5. This becomes 4 times 0. This becomes 0. So right here, everybody, you can go to here. That's fine. Okay. But what happens here, it's indicating how the limit laws work. And so the answer obviously is 3 over 5. And if you look at the graph, also the graph indicates that the horizontal asymptote y equals 0.6 or 3 over 5, by the way, 0.6 or 3 over 5 are identical, right? And so as you take the limit of this function, call it f of x over y, x is approaching infinity. For negative infinity works the same way. So the limit of this function, let's call it f of x, as x approaches minus infinity is the same way, because if you have infinity or minus infinity, makes no difference. The technique is to divide by highest degree term in the denominator, namely x squared. Infinite limits at infinity. The notation limit of f of x as x approaches infinity is used to indicate that the value of f of x becomes large as x becomes large. Similar meanings are attached to the following symbols. So look at all the symbols. Limit of f of x as x approaches minus infinity is infinity. Limit of f of x as x approaches infinity is minus infinity. Limit of f of x as x approaches minus infinity is minus infinity. So, and again, all of them refer to the concept known as the end behavior that you've heard and you're familiar with from algebra. So, as we look at all of these functions, y equals e to the power of x, y equals x squared, y equals square root of x, y equals ln x, all of them, if you look at the first quadrant means the limit of f of x as x approaches infinity is infinity in all cases. Of course, some, uh, you know, grow much faster. Uh, some don't, but the fact remains that the limit of f of x as x approaches infinity is infinity. And again, reminding you of the cube function, y equals x cubed, the limit of f of x as x approaches infinity is infinity, just like this one. But the limit of f of x as x approaches minus infinity is minus infinity. And this again refers to the end behavior that ends up with the third quadrant in this case. So how do we find limits? To find the limit, just plug in and observe. When we do so, what do we get? The limit of f of x as x approaches a is a number, you're done. The limit of f of x as x approaches a is 0 over some other number than 0. It's equal to 0, and you are done. The limit of f of x as x approaches a is some number over 0, something other than 0. So any number over 0, you learned in the past it was undefined, but actually it becomes either infinity or negative infinity, and we have to figure it out. And I'll show you how to do that as we come across that. However, in calculus, most of the time we end up with indeterminate forms. That means when we take the limit of f of x as x approaches a, we end up with 0 over 0, infinity over infinity, infinity minus infinity. All of those formats are indeterminate forms, and anything can happen. They can go to 0, they can go to infinity, or they can go to any number in between. Okay? That's why they are called indeterminate. The limit of 5t plus 7 over t squared plus 2t minus 1 as t approaches infinity. And I hope you realize if you plug in infinity, the top becomes infinity, the bottom becomes infinity. So you get infinity over infinity, and it's indeterminate. What does indeterminate mean? As far as I'm concerned, it means more work. It means use your algebraic technique to find the answer. Now, whenever you have a rational expression where the variable approaches infinity, remember the technique? We repeat the same technique. Divide by highest degree term in the denominator. So let's divide every term in the numerator as well as the denominator by t squared. Now we're going to simplify each term. This one is 5 over t, 7 over t squared. This one is 1, 2 over t, minus 1 over t squared. And right here, remember, I showed you with the warm-up example, you apply the limit to the top and the bottom, you separate them. You don't have to. Because t is approaching infinity, this goes to 0, this goes to 0, this goes to 0, this goes to 0, but 1 remains. And I want you to see that we have 0 plus 0 over 1 plus 0 minus 0, meaning you have 0 over 1, which is 0. The reason I want to write it in this fashion, because I don't want anybody to mix it up with 0 over 0, because if it is the case, that is indeterminate. So the answer is same thing. You have a rational expression, t approaches infinity, you divide by highest degree term in the denominator, because if you plug in, you get infinity over infinity, everybody. If you plug in, infinity over infinity. So that's the technique. Divide by t in this case, because t is the highest degree term in the denominator. And so you divide each one by t. And now we are going to simplify. This one is t, this one is 2, this remains, this one is 5, this remains. And now we are going to replace the t with infinity. When we do that, this becomes infinity plus 2 plus 0. This becomes 5 plus 0. Remember, 7 over infinity, okay, is 0. And so you have infinity plus 2, which is still infinity, divided by 5 or times 5 or divided by 10 billion is still infinity. Okay, everybody? Infinity times any number is infinity unless it's negative, becomes negative infinity. Okay, for example, if this was negative 5, then you would write negative infinity. The limit of the square root of x squared plus 1 minus x as x approaches infinity. This is another one of those indeterminate forms. If I plug in infinity, the square root of infinity squared plus 1 is infinity minus infinity. We get infinity minus infinity. And infinity minus infinity is indeterminate. It can go to 0. It can go to any number in between. It can go to infinity. So you can't assume infinity minus infinity is 0. It's indeterminate. You have to show what it becomes. So the technique, when you have square root, is to multiply by the conjugate. Remember, the conjugate of a minus b is a plus b. Their product is a squared minus b squared. So the conjugate of this expression is the same thing. Change the negative to positive. So you're going to multiply by it. You also divide by it because this expression, this fraction, must be equal to 1. Otherwise, you can't just multiply by any number you want. To do so, we write the conjugate of square root of x squared plus 1 minus x, and we divide by. When we do that, the denominator doesn't change. It remains. In other words, if you extend that, the denominator is square root of x squared plus 1 plus x. But what is the numerator? Following this, the numerator is the square root of x squared plus 1 quantity squared minus x squared, which means x squared plus 1 minus x squared. And now, if you put the infinity, the denominator is infinity plus infinity, and any number, doesn't matter how large it is, over infinity is 0. So, again, one might say, okay, I knew it was 0 because it was infinity minus infinity. That's not the case because sometimes you end up with a different answer, okay? Sometimes you end up with infinity. Sometimes you end up with some number in between, okay? So that's not a correct assumption. This is the proper methodology. All right. The limit of 12 over 4 plus 3 e to the power of minus t as t approaches infinity. Just plug in. You get 12 over 4 plus 3 e to the power of minus infinity. And so that becomes 0. Why is that? A to the power of minus m is 1 over a to the power of m. E to the power of minus t is 1 over e to the power of t. So this part is 1 over e to the power of t, or 1 over e to the power of infinity, which is 1 over infinity, which is 0. So 12, so this is 0. 12 over 4 equals 3 is the final answer. All right. The limit of 5 plus e to the power of t over 4 minus 3 e to the power of t as t approaches infinity. So what happens when we plug in? If we plug in, we get 5 plus e to the power of infinity. So we get infinity in the numerator. 4 minus 3 e to the power of infinity. This is infinity times negative makes it negative. So the numerator is infinity. The denominator is negative infinity. And that's indeterminate. So what is the technique we can use here? As you recall, in the case of a rational expression, when the variable is approaching infinity, we would divide by highest degree term in the denominator. In this case, we don't have polynomials, but we follow the same methodology by dividing by the highest value in the denominator, which is e to the power of t. Divide everything by e to the power of t. And this is 1. This is negative 3. Now, if t approaches infinity, e to the power of t approaches infinity, this becomes 0. This becomes 0. You have positive 1 over negative 3, which is negative 1/3. All right. So again, I emphasize, for a case like this, you have to divide by highest value in the denominator, namely e to the power of t. And what about this one? If you plug in infinity, you get infinity squared, which is infinity minus infinity. So again, an indeterminate form. So what's the technique? Factoring. Let's factor the x out, everybody. The limit of x times x minus 1 as x approaches infinity. And now if you replace the x, you get infinity times infinity minus 1, which is again infinity. Infinity minus 1 or infinity minus 10 billion is still infinity, everybody. Their product is infinity. The only thing you want to be careful if the product becomes negative, okay? So in this case, again, we ended up with something different. If you look at what we did in the previous page, infinity minus infinity, the example in the previous page gave us 0, and now it gave us infinity, and in other cases might give us a different value. That's why it's indeterminate, and you have to work on it using your algebraic techniques. And so you want to be careful with that. We look at this and we see the expression is a rational expression. This one would be a fractional expression, okay? A rational expression, x is approaching infinity. By the way, if you plug in, the top becomes infinity squared plus infinity, which is infinity. The bottom is 3 minus infinity. So it's infinity over negative infinity. I want you to know that. So the technique is, because x is approaching infinity, divide by highest degree term in the denominator, namely x. So let's do that. So divide by x. So if we divide by x, this becomes x, this becomes 1, this becomes 3 over x minus 1. And so when we plug in infinity, we get infinity plus 1 here. Over here, we get 0 minus 1. And that's what I want you to be careful. The numerator is infinity plus 1 or plus any number or minus any number is infinity. The top is infinity. Because the bottom is in a negative number, doesn't matter negative 1 or any other negative number, the result is negative infinity. So you want to be careful with that sign. Okay, everyone? The Pacific halibut fishery has been modeled by the equation B of t equals 8 times 10 to the power of 7 over 1 plus 3 e to the power of negative 0.71 t, where B of t is the biomass, the total mass of the members of population in kilograms at time t. What is the limit of B of t as t approaches infinity, and what does it mean? What is the significance of that? Well, we're going to take the limit first. See what we get, and we take it from there. So the limit of this expression as t approaches infinity, the limit of 8 times 10 to the power of 7 over 1 plus 3 e to the power of minus 0.71 times t. So basically you plug in. If we plug in, the numerator doesn't change, 1 doesn't change. Let's see what happens here. I want to explain this part. So this one, when you plug in, you get 3 e to the power of minus 0.71 times infinity is minus infinity. And e to the power of minus infinity is 0. Therefore, is 8 times 10 to the power of 7. Because, again, negative exponential rule, a to the power of negative m is 1 over a to the power of m, or e to the power of negative t is 1 over e to the power of t. So this part becomes e to the power of negative 0.71 times infinity, which is negative infinity. And this part is 0. So if this is 0, then you have 8 times 10 to the power of 7 kilograms. That means 8 with 7 zeros. That means 80 million kilograms. So what? What does it mean? What is the significance of this? We found the limit of B of t, which is the total mass. It means in a long run, the Pacific halibut biomass will be 8 times 10 to the power of 7 kilograms. In other words, 80 million kilograms. Scientific notation, decimal notation, or standard notation. A tank contains 5,000 liters of pure water. Brine that contains 30 grams of salt per liter of brine is being pumped into the tank at a rate of 25 liters per minute. Show that the concentration of salt after t minutes in grams per liter is B of t equals 30t over 200 plus t. So first we want to do some algebraic steps. So first and foremost, everybody, the concentration of salt. That means in grams per liter, that means the amount of salt in grams over the amount of liquid in liters. That's what we are looking for, okay? So we want to find this. So the amount of salt goes to the numerator, the total amount of liquid goes to the denominator. All right. So starting with the liquid, we have 5,000 liters to begin with. Then we are adding brine at the rate of 25 liters per minute. So 25 liters per minute of brine is added. As far as the bottom is, would be 5,000 plus this much over the course of so much time. Okay, so after 10 minutes. Before we start with the 10 minutes, if it's 25 liters per minute, everybody, I just want to make sure we understand that. So after 1 minute, we add 25 liters, right? Because it's 25 liters per minute. After 2 minutes, we add 2 times 25, 50 liters. After 10 minutes, 25 times 10, we add 250 liters. So for example, if we stopped at 10 minutes, that means the liquid would be 5,000 liters plus this much. But we are going to stop at T minutes. So after T minutes, okay, now we have 25 times 1 here, 25 times 2 here, 25 times 10 here, 25 times T liters here. 25 times T is the amount of brine that has been added after T minutes. So that is the amount. 25 T will be added to 5,000 for the bottom, which is the liquid form. What about the numerator, which is a salt? Well, brine contains 30 grams of salt per liter. So if we add 1 liter, we get 30 grams of salt. So let's look at this concept now. So 1 liter gives us 30 grams. 2 liters gives us 2 times 30. 5 liters gives us 5 times 30 grams adds, okay? So 10 times 30, right? So whatever the number of liters. So how many liters do we have? 25 T. So after T minutes, we have 25 T liters of brine, therefore times 30 is the amount of salt in grams. So that's the amount of salt, 25 times T times 30, which is 750 T grams. And the liquid is this plus that. So the amount of salt is 25 T times 30, which is 750 T grams of salt. The amount of liquid is what we had and what we are adding, 25 T. So for this one, we're going to put the numerator, the amount of salt, 750 T, and for the denominator, we're going to put 5,000 plus 25 T. This is in grams, this is in liters. And I hope you recognize both of them, the top and the bottom are divisible by 25. So let me erase my work, by the way. So now here, divide everything by 25. In other words, factor 25 out. This becomes 25 times 30T. Never mind the units. We know what the limits are, the units are. This is grams per liter. This, if you take the 25 out, this becomes 200. This becomes T. I can cancel out the common factor of 25. And that is the proof This is fine. And believe it or not, this was algebra. All right. So the first part was algebra, and now this is calculus. This is what happens as t approaches infinity. In other words, find the limit as t goes to infinity. That's the part that is calculus. So we want to find the limit of b of t as t approaches infinity, which is the limit of 30t over 200 plus t as t approaches infinity. We have a rational expression, and t is approaching infinity. So rational expression, t is approaching infinity. Since t is approaching infinity, we divide by highest degree term in the denominator, namely t. Divide everything by t and simplify. So the limit as t approaches infinity of 30t over t, which is 30, 200 over t, which is 200 over t, plus 1. That's what we get. Now, since t approaches infinity, 200 over t becomes 0. And the answer is 30 with the units of grams per liter. And this is the significance of that. So what? What does it mean? Then we have brine that had 30 grams of salt per liter. Why is that the same? The idea is this. Although we have a lot of pure water, 5,000 liters a lot. If you continue indefinitely, you add so much brine that eventually this much water is nothing compared to that. So in a long run, all the liquid in essence turn into brine. We still have the 5,000 liters of pure water, but it's nothing compared to what you do if you continue indefinitely. Therefore, the result, the mixture will be just like the brine we had in the first place, which is 30 grams of salt per liter of brine, and that doesn't change. And that's the idea behind the limits. And it's important to understand what happens in a long run in this case.